Hey, wanted to demo some basics of using entities in Foobara. So the plan for today is to install Foobara, create an executable Ruby script. We're going to make a Capybara model. It's just going to have a name and age to keep things simple. We'll go ahead and upgrade our model to an entity, and we'll add an InMemory crud driver so that we can read and write Capybara records to and from memory. And we'll play around a bit with transactions, and we will switch to a Redis crud driver so that we can persist our Capybara records across invocations of our Ruby script. All right, so let's dive in. So let's make an executable Ruby script real fast. I'll just print out hi because I'm too lazy to type hello world. Make it executable. All right, let's install Foobara. Let's go ahead and require it. And let's create our Capybara model. We do so like this. Name, age, and let's create a few Capybara model instances. Let's create Fumiko for foo, Barbara for bar, Basil for baz. And these are some old-ass capybaras. And I'm just going to print out their ages for now to test that out. We'll see if this works. All right, looks good. So let's go ahead and create an increment age command. It will just increment the capybara's age by 1. So we'll take a capybara as inputs. We'll return a capybara. I like to make sure that the execute method is self-documenting, so we will need a increment age helper method. And I'm going to drop into an IRB session so that I can play around with it interactively and not have to rerun the script as frequently. But that does mean I won't have access to local variables, only global variables and constants. So I'm going to make this capybara's array global. All right, let's get a handle on Fumiko. And let's increment Fumiko's age. Let's do it a bunch of times. Okay, so now Fumiko is 106, so we ran it 6 times. Now, something interesting I want to show you. What do you think will happen if we do this? If we pass in capybara attributes to increment age instead of a capybara model instance. Well, it will actually cast it to a capybara model instance for us, which is helpful in many contexts. All right, so now I want to upgrade Capybara from a model to an entity. Entities are like models. Well, entities are models, but they have a primary key, and CRUD drivers know how to read and write them to and from some storage. For now, we will just read and write them to memory. So let's go ahead and create an in-memory CRUD driver. And I'm going to set it as the default. And let's go ahead and make a create capybara command so that we can create our capybara records. So we'll take capybara attributes as inputs, and the result will be a capybara. And this time we want a piece of runtime context, which will be the capybara itself. So I'm going to make a Capybara attribute accessor. And I'll call create, passing in the inputs. Okay, I'm going to switch these to use our create capybara command. I don't know how to do multi-line edit in this editor, so I'll just do a search and replace. I'll make these global, just in case I want to grab one. And these need to be run, not new. Okay. And finally, let's change this to an entity. We need a primary key. We'll call it ID, and we have to tell Foobara which one the primary key is. All right, let's play with this. So we can see Fumiko was created successfully here. Let's look at its attributes. Has an ID of 1. So let's try loading it directly and see what happens. So we get an error because there's no transaction open. In Foobara, you really should not be creating entities outside of commands. When you are creating records inside of commands, the transactions are all handled for you. But when creating them outside of commands, it gets a little awkward because you should not be doing that. You should be building a command-centric system where everything is happening through commands, and commands are the public interface to the system. So let's go ahead and wrap this in a transaction, though, just so that we can get it loading. Okay, so now we are able to successfully load it. I'm going to create a helper method so I don't have to type as much when I need a transaction. Let's test it out. Okay, that works, and I'm going to put it in the script, actually. That's where I really need it. That way I don't lose it when I reload the console. Okay, Capybara. All right, so now let's get a handle on this capybara, and let's see what happens if we try to increment its age. It's currently 100. So what do you think will happen here? Well, we get another transaction error. And the problem here is that we loaded this capybara from one transaction, closed it, and are now trying to use that record in a new transaction, which is not allowed. So if we want to do this, we need to load the capybara inside the same transaction that we are trying to manipulate it. So let's do that. Okay. Increment it. And there we go. So let's look at its age now. Should be 101 now. Yes, 101. Okay. Increment it again. Now it's 102. So something we can do in Foobara is we can use primary key values in place of records, and they will automatically be cast to that record. And this is actually really helpful for a number of reasons, but let's go ahead and demonstrate that. So instead of passing in the capybara from a different transaction which failed, let's just use its primary key. And there we go. We were able to successfully increment its age using its primary key directly. So now I want to play around with how transactions work in Foobara. They work intuitively the way you would expect them to. Meaning you open the transaction, you manipulate records, and when you commit the transaction, that's when it becomes properly persisted and visible to other transactions that are opened. And you get that in Foobara whether or not the underlying database technology supports it. And that can come in handy in a couple of key use cases. But anyway, let's dive into playing with this. So what I would like to do is be able to pause and resume execution. So I'm going to make a pause method, and we'll just implement pause by sleeping. And let's implement a resume. Okay, that should stop it from sleeping. I want to pause execution before we increment the age, and also after we increment the age, but before we commit the transaction. All right, let's make an instance of our command so we can have a handle on it. In Foobara, you don't have to run the command directly. You can create an instance of the command and delay running it to some other point in time if you want. That's helpful here because I want to run it in a separate thread of execution that I can pause and resume while being able to poke around in the data from the main thread. So let's go ahead and run this command in its own thread. All right, so our execution is paused. It's paused before we have incremented the age. So Fumiko's age should be 100 in all transactions. So let's first look at what Fumiko's age is inside the commands transaction. It is 100 as expected. And let's load one in a fresh transaction, and it's also 100 as expected. So now let's go ahead and resume, which should increment the age inside of the commands transaction and then pause, but before the commands transaction has committed. So we can see that inside the commands transaction, the age is 101. So inside the commands transaction, Fumiko's age is 101. Outside of the commands transaction, Fumiko's age is 100. And it's not just that the command has a handle on a record that has been set to 101. For example, let's load a fresh record of Fumiko inside the commands transaction and look at her age. So transactions, there's only one transaction. Let's load it and check the age. So 101. So Fumiko's age is 101 inside of the commands transaction. So now let's go ahead and resume this and allow the transaction to commit. The expectation here will be now we have committed the transaction. All transactions should now see Fumiko's new age of 101. So happy birthday, Fumiko. And let's take a look. So the record that the command is holding on to in its execution context has an age of 101 as expected. If we go ahead and load Fumiko in the commands transaction and check its age, it's also 101 as expected. But more importantly, if we create a new transaction outside of the command, we also see that Fumiko is 101 now. All right, so now I think we can get rid of our pause and resume helper methods or functions, however you want to call them. And now I want to show you something kind of interesting. Do you remember before when we passed the Capybara attributes to increment age when Capybara was a model? I want to see what happens if we do that now that Capybara is an entity. First, I want to show you how many capybaras there are, which might give away where we are going with this. So we have 3 capybaras. Let's go ahead and increment Fumiko's age for the heck of it. And we still have 3 capybaras. So now let's call increment age with capybara attributes. And now what is this? A capybara with an ID of 4 has a new name. So what has happened here is Foobara has automatically created a capybara record for us, which in some contexts is extremely convenient, in particular when constructing nested aggregate models and entities. However, this could be kind of surprising as well, so maybe this shouldn't be the default behavior, but for now it is. But I did want to just demonstrate that behavior. So now the only thing left is when we reran this script, we started back at 3 capybaras. So we are not persisting these records between runs of our script. Let's go ahead and switch to a different CRUD driver that will give us persistence across invocations of our Ruby script. So let's install a Redis CRUD driver. Okay, and let's make use of it. So we're going to swap out the InMemory crud driver with a Redis crud driver. And the Redis crud driver is it's an inconsistent namespacing here. It probably should be made consistent. I'm just going to point it at the local Redis. Okay, and now let's rerun our script. So we have 3 capybaras as expected, but let's run it again. And now we have 6. And run it again. We have 9. And we can look at all their names. We can see Foobara Baz alternating. And let's go ahead and increment Fumiko. Do it a bunch of times. And 105. Now let's exit and come back in and check her age again, and it is 105. So now our mutations are surviving across runs of our script. And that concludes our demo. Thanks for watching. A lot more to say, but I'm going to try to keep these videos shorter. So yeah, thanks again. Peace.